questions. I assigned cold pack part 1 and cold pack part 2. So we're going to look at cold pack part 1, and it actually has 4 parts to it. And I'll show you how to do one, and then you should be able to do the others, but if you don't, come back and ask questions. And then if you can't do the second one, just come back and ask questions. So let's look first at what the question says. It says, using the salts provided in the VL cabinet, determine the heat of solution of magnesium sulfate, potassium nitrate, and ammonium nitrate. And then it says to create a calorimeter in the virtual lab, right-click any piece of glassware and choose Thermal Properties. In the Thermal Properties dialog box, click Check Insulate. Assume the calorimeter container does not absorb any heat and that the specific heat for the solution is 4.184 joules per gram Kelvin. I have read that even though Kelvin is a measure of temperature, you don't actually say degrees Kelvin, you just say Kelvin. So there's a degrees there, but we'll ignore that. We'll just say per gram Kelvin. Same as for water. The virtual lab is set up to enable you to determine the literature values for the heats of solution which are required in the wet lab. To ensure that the amount of solid added to the calorimeter is accurately recorded, the mass of the salt should be weighed out by differences. Turns out this doesn't really matter in this lab, but I'll show you what they mean. Click on the solid button in the solution information window on the right, highlight the jar of salt to see the mass of the solid, transfer the required amount to the calorimeter, and check the mass of the salt again. Okay, so that's what the problem description says. Now, basically what you're trying to do is to figure out what delta H is for the following reaction. So you take magnesium sulfate as a solid, and then you dissolve it and when you dissolve it, you get the magnesium ion and the sulfate ion. So this is actually a reaction, and so it'll have some delta H associated, and we call that delta H of solution. So what is the delta H for when you dissolve magnesium sulfate? Okay, now we'll figure this out by looking at the change in temperature of the water. So if the temperature goes up, would the reaction be endothermic or exothermic? Exothermic. And would delta H be positive or negative? Negative. And then vice versa. And sometimes when you dissolve things, it's endothermic, and sometimes it's exothermic. So we'll want to look and see what happens. So the idea is we're going to put some water, and we're going to put some magnesium sulfate, and we're going to dissolve some in the water, and then we're going to see how much the temperature changes. Now, obviously, the amount of magnesium sulfate we put in will make a difference as to how much the temperature changes. Now, we're supposed to be finding we're finding delta H, so we'll want to find out what it is per mole. Now, we're not going to want to put a whole mole in because a whole mole won't dissolve in the water. So we'll want to put enough in so that we can determine the temperature change, but we don't want to put so much in that it doesn't all dissolve. So before we actually get started, let's just look and see what a reasonable amount to put in might be. So I'll put some water in there, and I'll put some magnesium sulfate. Now what they mean by weighing by differences is if I have this magnesium sulfate, and I've got that highlighted, if I click over here on solid, it shows me how much I have. I have 2.2870 times 10 to the second, so 228.7 grams. And then after I put some in, I'd go back and check and make sure the amount I took out equals the amount I think I took out. Well, so far with every one I've done, it does, so I'm not going to actually go back and check that. So I'm going to pour some magnesium sulfate in. So how much do y'all want to put in grams? Remember, a paper clip is about is it a gram or 5 grams? Well, anyway, that gives you an idea. So, oh, I forgot something first. First, I'm supposed to make my flask a calorimeter. So I right-click on it, and I choose Thermal Properties. And I'm going to choose Insulated from Surroundings. I could also set the temperature here, but I'm going to leave it at 25. 5 grams? 5 grams? 5 grams sounds good to me. So I'll pour that in. And notice our temperature went up to 33.03 degrees Celsius from 25. That seems like a reasonable amount. I may not need to go back and change this. And the one other thing I want to check is to make sure it all dissolved. So I'm going to click on my flask here. And if I look in my flask, it says it has 0 grams of solid magnesium sulfate. So that means it did all dissolve. Okay. So if it didn't all dissolve, or if I didn't get a high enough temperature change, I might start over and use a different amount. So we had 5 grams magnesium sulfate, and delta T is 33.03 minus 25. So do we have endothermic or exothermic? Exothermic, because it's releasing heat. I guess I can leave this on. Okay, now we're going to be saying the specific heat is the same as the specific heat of water, which eventually you'll probably know that, but if you don't, it's 4.184 joules per gram Kelvin. All right, so now we're just going to use the equation that will tell us how much heat was given off in this reaction. So we'll say Q, because Q is our symbol for heat, equals the mass times the specific heat times the change in temperature. So first we need to figure out the mass. Well, we had 100 milliliters of water, and we added 5 grams of magnesium sulfate. So our mass?
105.
105. Our specific heat, 4.184 joules per gram Kelvin. And our change in temperature, 8.03. And since a degree Celsius is the same as a Kelvin, we can go ahead and put that in there. Now, if y'all want to check, I'm notoriously bad for making calculator mistakes. So I get 3,527.74 joules. My grams cancel, my kelvins cancel, so that's why I'm left with joules. And even though our answer says to leave it in 3 significant figures, I'm going to leave a bunch of them until I get to the end, and then I'm going to run. Okay. So what I actually found was 3,527.74 joules is what you get if you dissolve 5 grams. But I'm really interested in what it is per mole. So my next step is to figure out how many moles I have in 5 grams of magnesium sulfate. So start with 5 grams of magnesium sulfate. And then in 1 mole of magnesium sulfate, I need to figure out how many grams. So could someone get, I've got my handy dandy portable periodic table behind the door. Yeah, that's it. Yeah. So just, whenever you need one, I always have one handy. So magnesium, someone read off to me what that is.
24.50.
Plus sulfur?
32.066.
And then I need 4 oxygens.
2.9994.
Okay, yeah. So that was handy to have that. I get 120.369 grams. Okay. So if I divide 5 by that, I get that my 5 grams was 0.041539 moles. So if my heat for 5 grams was 3,527.74 joules, and that was how many moles I had, then my delta H for solution should be 3,527.74 joules divided by 0.0539 moles. And I get 84,925.8 joules per mole. Now my answer, when I put it in, is supposed to be in kilojoules per mole. So this would be 84.9258 kilojoules per mole. But now I need to go back to the question I asked at the beginning, which was this endothermic or exothermic? Exothermic. So I need to actually make this negative, and it says please use 3 significant figures. So my actual answer should be negative 84.9. Yay, my answer is correct. Okay? So you'll do the same thing for these 3, and then you'll use these results to do part 2 of the lab. And then if y'all have questions about that, you can come back and ask. I know you make sure you pay attention to whether it's endothermic or exothermic as to whether you put a negative sign or a positive sign. So the steps are you figure out how much you want to put in, and then you're going to figure out your heat is your mass times the specific heat times the change in temperature. So you get that off of here. This is going to be 100 plus however much stuff you put in. This is always 4.184 if you're dealing with water. Then you take this answer and you divide it by the molecular weight of your compound. And then make sure you put your answer to 3 significant digits. Does that make sense? Okay.
And for the coffee problem,
Yes.
every time we try to put the answer in, it would be like you're correct, and then the screen would go away, so we didn't have time to print it.
Oh, so you got it correct, and then the screen would go away?
Yeah.
Okay.
Just like show us your.
I just wrote down the work.
Yeah,
and
write
then
down the
bring that-
work. Yeah,
Okay.
write down the work.